Tonight, we follow the life of Carl Sagan, a scientist who dedicated his life to bringing the wonders of the universe closer to everyone. He showed us that the story of the stars is, in many ways, the story of ourselves. Welcome to the Orbit for Sleep channel. Here, science moves slowly, quietly, and without urgency. Let us follow the orbit of science and drift gently towards sleep. In the year 1934, the city of New York was a place of brick, stone, and the constant hum of life. In a quiet corner of Brooklyn, a child named Carl was born into a world that was just beginning to look upward. The 20th century was an era of transformation, yet for a young boy, the immediate world consisted of the narrow streets and the small patches of sky visible between the apartment buildings. At night, the street lamps cast a warm, yellow glow on the pavement, but Carl was often more interested in the lights that the lamps could not reach. He noticed the steady, white points scattered across the dark velvet of the night. To him, they were mysterious and silent observers of the city. One afternoon, when he was very young, he walked with his mother to the local public library. The building was a place of silence and the scent of aged paper. He walked to the wooden desk and spoke to the librarian. He asked a simple question about the nature of the stars. The librarian gave him a book about the heavens. He sat down and turned the pages, discovering a truth that changed his perception of reality. The book explained that the stars were not just lights, but suns. They were immense and powerful, identical to the sun that warmed the Brooklyn streets, only positioned at distances so vast they appeared as mere sparks. This realization did not bring fear, but a profound sense of stillness. The world felt larger, and his place within it felt both small and significant. In 1939, his family visited the New York World's Fair. He stood before the massive, white structures of the Trilon and Perisphere. The air was filled with the sounds of progress and the visions of a future shaped by science. He saw exhibits of streamlined trains and silver ships that promised to carry humanity into the unknown. The fair presented a world of order and technological harmony. For Carl, the experience was a confirmation that the curiosity he felt in the library was shared by others. He walked through the world of tomorrow and felt the weight of the future. The evening air was cool as he left the fairgrounds, and the first stars began to appear. He understood that the story of humanity was beginning to move beyond the streets of New York. The quiet rhythm of the universe was a constant presence, waiting for those who were willing to look and listen. He returned home, but his mind remained among the distant suns. In the mid-20th century, the public library became a sanctuary for Carl. He found himself returning to the same heavy wooden doors, where the air was still and carried the faint, comforting scent of aged paper and binding glue. Inside, the world of Brooklyn noise vanished, replaced by a profound silence that allowed his thoughts to expand. He spent long afternoons navigating the narrow aisles, guided by the gold-lettered spines of books that promised to explain the nature of everything. He eventually found the section dedicated to astronomy. He reached for a volume that contained detailed charts of the planets. Moving his fingers across the printed ink of distant worlds, he read about Jupiter, a massive sphere of gas so large that it could swallow all the other planets in the solar system. He learned about the rings of Saturn, which he discovered were not solid disks, but millions of individual pieces of ice and rock, each following its own orbital path in a silent cosmic dance. In 1947, the 13-year-old boy began to understand that science was a language that could be learned. he realized that the stars were not unreachable mysteries, but physical entities that obeyed the laws of nature. The library provided the tools he needed to translate the light from the sky into knowledge. He sat at the long reading tables, surrounded by other silent seekers, and took notes on the chemistry of the sun and the physics of gravity. You noticed the steady rhythm of his pen as he recorded the distances between galaxies, measured in units that stretched his imagination far beyond the city limits. The library was no longer just a room full of books. It was a vessel that carried him across the light years, while his body remained stationary in a wooden chair. When the library closed for the evening, he often took his questions to the flat roof of his apartment building. The 20th century city surrounded him with its own artificial glow, but his eyes were trained to look past the streetlights. You feel the coolness of the night air as he adjusted a small, modest telescope he had managed to acquire. Through the lens, the moon was transformed from a flat, white circle into a rugged landscape of craters, mountains, and vast, frozen lava plains. He stood there for hours, a solitary figure against the urban skyline, connecting the facts he had read in the library to the reality of the celestial objects above. He understood that the craters he saw were the result of ancient impacts, and that the shadows lengthening across the lunar surface were evidence of a sun casting its light across the vacuum. The rooftop became his private observatory, a bridge between the dusty shelves of the library and the infinite depths of the night sky. He was learning that the universe was vast, yet it was also a place where a curious mind could find a home. In 1951, at the age of 16, Carl arrived at the University of Chicago. The campus was a collection of gray limestone buildings with Gothic arches, where the 20th century intellectual tradition was being shaped by a unique approach to education. He entered the Hutchins program, which emphasized a broad understanding of the humanities, philosophy, and history alongside the natural sciences. You noticed the shift in his perspective as he moved between lecture halls, carrying books by Plato and Shakespeare alongside his physics texts. This interdisciplinary environment taught him that science was not an isolated discipline, but a part of the larger human story. He spent his days in the quiet corridors of the university, learning how to structure an argument and how to view the world through a lens of critical thinking. As the years progressed into the mid-20th century, his focus sharpened toward the physical sciences. He moved into the laboratories and observatories, where the abstract theories of his youth began to meet the rigor of mathematical proof. In 1954, he earned his bachelor's degree and continued his journey into the deeper complexities of physics and astronomy. He became a student of Gerard Kuwer, a prominent planetary scientist who encouraged him to look at the worlds within our own solar system with renewed curiosity. You imagine the long nights he spent at the Yerkes Observatory, where the large refracting telescope stood as a silent sentinel against the dark Wisconsin sky. The rhythmic ticking of the telescope's tracking motor was the only sound in the vast, cold dome as he waited for the light of distant planets to be captured on photographic plates. By 1960, the young student had transformed into a professional scientist, completing his doctorate with a focus on the physical environments of the planets. His research was characterized by a willingness to challenge established ideas, such as the prevailing belief that Venus was a tropical paradise. He used the laws of thermodynamics to suggest a different reality, proposing that the planet's thick atmosphere trapped heat in a runaway greenhouse effect. You see him defending his dissertation, presenting data and logic with a calm and steady voice. The University of Chicago had provided him with more than just a degree. It had given him the intellectual foundation to bridge the gap between complex data and the human imagination. He left the university not just as an astronomer, but as a scholar who understood that the study of the stars was fundamentally a study of ourselves. In the early 1960s, Carl moved his research to Harvard University and the Smithsonian Astrophysical Observatory. His mind remained fixed on the fourth planet from the Sun, a world that had occupied his imagination since he was a young boy, reading stories of Martian civilizations. During the early 20th century, many people still imagined Mars as a place of intricate canals and dying empires, a vision fueled by the sketches of earlier astronomers. You notice how Carl transitioned from these childhood fantasies to the rigorous application of the scientific method. He understood that to truly know Mars, one had to look beyond the telescope and send instruments across the void. He became a leading member of the teams planning the first robotic explorations of the Red Planet, bridging the gap between ancient dreams and modern technology. In 1971, the Mariner 9 spacecraft reached Mars, becoming the first vehicle to orbit another planet. When the craft arrived, a massive dust storm obscured the entire surface, leaving only a few dark spots visible against a sea of orange clouds. You imagine Carl waiting patiently in the control room as the dust slowly settled over the following weeks. As the air cleared, the cameras revealed a world far more complex than anyone had anticipated. Instead of the flat, featureless plains many expected, the images showed massive volcanoes, including Olympus Mons, which stood 3 times taller than Mount Everest. You see the wonder in his eyes as the data revealed Valles Marineris, a canyon system so long it would stretch across the entire United States. These discoveries proved that Mars was a geologically active world with a history written in its rocks and craters. Carl was particularly interested in the winding valleys that resembled dry riverbeds on Earth. These features suggested that in the distant past, liquid water had once flowed across the Martian surface. He proposed that the thin, cold atmosphere of the 20th century Mars was not its original state. He envisioned a younger, warmer Mars where clouds moved through the sky and rain fell upon the red soil. This realization shifted his focus toward the possibility of life. While the Mariner missions did not find cities or canals, they found a world that could have once supported microscopic organisms. You feel the steady progression of his thought process as he began to plan for the next stage of exploration, the Viking missions, which would finally touch the Martian soil. To Carl, Mars was no longer a setting for science fiction stories, but a real place of sand, wind, and ancient mysteries that required careful investigation. He taught the world that reality was often more spectacular than the myths of the past. By the late 1960s, Carl realized that the discoveries made in laboratories and through spacecraft missions remained largely hidden from the public eye. While the exploration of Mars and Venus was expanding the boundaries of human knowledge, the language of science often felt inaccessible to those outside the academic circle. You notice the transition in his career as he moved to Cornell University in 1968, where he began to refine a unique skill that would define his legacy. He understood that the wonders of the universe were a shared heritage of all mankind, and he felt a responsibility to act as a translator between the complexity of the stars and the curiosity of the human heart. He began to dedicate as much time to the art of communication as he did to the rigors of planetary research. In the 1970s, he became a frequent guest on national television programs, most notably The Tonight Show. You see him sitting in a chair, dressed in a simple turtleneck and jacket, speaking to millions of people about the vastness of the cosmos. His voice remained calm and steady, devoid of the aggressive certainty that often characterized scientific debates. He spoke about the billions of stars and the immense spans of time with a rhythm that invited listeners to contemplate their own place in the universe. He used clear analogies, comparing the history of the Earth to a single day, or the elements of our bodies to the debris of dying suns. He demonstrated that one did not need a specialized degree to appreciate the elegance of a mathematical law or the beauty of a distant nebula. His approach to explaining science was rooted in a deep sense of democratic values. He believed that a society shaped by technology and science required a citizenry that understood the basic principles of how the world works. You feel the weight of his conviction as he wrote books that reached people in every corner of the globe. He avoided the style of a lecturer and instead adopted the tone of a fellow traveler on a journey of discovery. He showed that science was not a collection of cold facts, but a way of thinking, an ongoing process of questioning and refinement. By the end of the 20th century, he had become the most recognizable face of astronomy, a man who could explain the birth of a galaxy and the structure of a cell with equal clarity. He provided a voice for the universe, ensuring that the light from the most distant reaches of space could be felt and understood by everyone on the ground. In 1960, as the space age began to unfold, Carl turned his attention to Venus, the planet often called Earth's twin due to its similar size and mass. During the 20th century, many astronomers believed that beneath the thick, eternal clouds of Venus lay a world of lush jungles and vast, humid oceans. They imagined a tropical paradise, perhaps teeming with exotic life, similar to the swampy forests of Earth's ancient history. You notice Carl's quiet skepticism as he examined the data provided by early radio telescopes. Instead of accepting the romanticized visions of the time, he applied the laws of physics to the invisible signals coming from the morning star. He analyzed the radio waves and found that the surface of Venus was far hotter than any tropical swamp could ever be. In 1962, his theories were put to the test when NASA launched the Mariner 2 mission, the first successful planetary flyby. As the spacecraft approached the clouded world, Carl waited for the signals that would confirm or refute his calculations. You imagine him standing in the control room, surrounded by the hum of early computers and the steady glow of monitor screens. The data began to arrive, revealing a reality that was far more hostile than the myths of the past. The surface temperature was nearly 480 degrees Celsius, hot enough to melt lead. The thick clouds were not made of water vapor, but of concentrated sulfuric acid. Carl realized that Venus was not a paradise, but a world trapped in a runaway greenhouse effect. He explained that the dense carbon dioxide atmosphere of Venus acted like a heavy blanket, allowing sunlight to enter, but preventing heat from escaping back into space. This discovery was a significant milestone in the 20th century understanding of planetary science. You hear him documenting the findings, noting how the delicate balance of an atmosphere could determine the fate of an entire world. For Carl, the study of Venus was not just an exercise in astronomy. It was a lesson in the fragility of planetary climates. He understood that by studying the extreme conditions of other planets, humanity could gain a deeper appreciation for the unique and stable environment of Earth. The silent, scorching plains of Venus served as a quiet reminder of the power held within the invisible gases of an atmosphere. He continued his work, always looking for the hidden truths beneath the clouds. In the year 1976, the focus of the scientific world shifted to a dusty plain on Mars known as Planitia. This was the year the Viking 1 lander successfully touched down on the Martian surface, marking the first time a sophisticated laboratory had been placed on the red soil. For Carl, this moment was the culmination of decades of anticipation. You noticed the quiet intensity of the control room as the first color images began to appear on the screens. The landscape was not the dark, jagged world some had predicted, but a vast, orange desert filled with smooth rocks and fine, rusted sand. The 20th century cameras revealed a sky that was not black, but a pale, pinkish orange, tinted by the dust suspended in the thin atmosphere. As the Viking landers began their work, Carl turned his attention to the orbital images of the surrounding terrain. He examined high-resolution photographs of winding channels that meandered across the Martian landscape for hundreds of kilometers. These features, such as Ares Vallis, bore a striking resemblance to the dry riverbeds found in the deserts of Earth. You see him tracing the paths of these ancient channels, noting how they branched and curved just as terrestrial rivers do when they flow toward a sea. The presence of these landforms suggested that billions of years ago, the Martian atmosphere was thick enough to allow liquid water to exist on the surface. He envisioned a distant era when the red desert was carved by the steady flow of rivers and the crashing of waves against ancient shorelines. Carl was deeply involved in the Viking biology experiments, which sought to detect signs of microscopic life in the Martian soil. The lander's robotic arm reached out and collected samples of the red earth, placing them into a miniature laboratory inside the craft. You imagine the stillness of the Martian plains as the instruments processed the soil, searching for the chemical signatures of metabolism. While the results remained ambiguous and did not provide clear evidence of life, Carl viewed the silence of the soil as an invitation to look deeper. He understood that the absence of life in the present did not mean Mars had always been a barren world. He continued to advocate for the idea that Mars had a golden age in its youth, a time when it was a warmer and wetter place. To him, the Red Desert was a silent archive of a lost history, waiting for the 20th century explorers to uncover the secrets of its ancient waters. In 1972, a small spacecraft named Pioneer 10 prepared to depart from Earth on a journey toward Jupiter and beyond. Carl understood that this mission represented a unique opportunity in human history, as the craft was destined to eventually leave the solar system and drift into the vast silence between the stars. He proposed that the spacecraft should carry a message, a small token of recognition for any civilization that might encounter it in the distant future. You noticed the simple design of the plaque he helped create, a small sheet of gold anodized aluminum bolted to the frame of the craft. It featured a diagram of the hydrogen atom, a map of our sun's position relative to distant pulsars, and the figures of a man and a woman. The 20th century engineers sent this silent greeting into the dark, knowing it would remain intact for millions of years. In 1977, the launch of the Voyager 1 and 2 missions provided an even larger canvas for Carl's vision. He was appointed as the chair of a committee tasked with creating the Golden Record, a more complex and ambitious message to the cosmos. This was a 12-inch gold-plated copper disc, housed in a protective aluminum jacket and accompanied by a needle and instructions for playback. You imagine the quiet concentration in the room as Carl and his team selected the contents that would represent our entire planet. They chose sounds of the natural world, including the rhythm of a heartbeat, the sound of a mother's kiss, and the complex songs of humpback whales. The record also contained music from diverse cultures, ranging from the classical compositions of Bach to the blues of Blind Willie Johnson. The Golden Record included greetings in 55 different languages, beginning with Akkadian and ending with modern Chinese. Carl wanted the message to reflect the unity of the human species, rather than its divisions. You feel the stillness of the vacuum as the Voyager crafts move further away from the sun, carrying these memories of Earth into the interstellar void. The 20th century technology used to create these records was designed for longevity, ensuring that the images and sounds would remain clear even after 1 billion years have passed. Carl recognized that the chance of the records being found was incredibly small, yet he viewed the project as a necessary act of cosmic communication. He saw it as a message in a bottle thrown into the cosmic ocean, a testament to the fact that we once lived, thought, and felt on a small, blue world. The crafts continue their silent journey, acting as the furthest ambassadors of human curiosity. In the mid-20th century, as astronomers focused their telescopes on the giant planets, Carl found himself drawn to a mysterious, orange-hued world orbiting Saturn. This was Titan, the largest moon in the Saturnian system and the only moon in the solar system known to possess a significant atmosphere. While most moons appeared as cold, cratered rocks, Titan remained a total enigma, its surface completely hidden beneath a thick, impenetrable veil of orange clouds. Carl suspected that this haze was not merely a collection of simple gases, but a complex chemical factory where the precursors to life might be forming. He viewed Titan as a planetary laboratory that could provide a window into the distant past of our own world. In the 1970s, Carl and his colleague Bishan Kare began a series of groundbreaking experiments at Cornell University to simulate the environment of this distant moon. You notice the methodical nature of their work as they filled glass flasks with mixtures of nitrogen and methane, gases they believed to be present in Titan's atmosphere. They subjected these mixtures to electrical discharges to mimic the energy from sunlight and lightning. Over time, a reddish-brown, tar-like substance began to accumulate on the walls of the flasks. Carl named these complex organic molecules tholins, a word derived from the Greek for muddy. These tholins were significant because they represented the organic building blocks that could, under the right conditions, lead to the origin of life. In 1980, the Voyager 1 spacecraft performed a close flyby of Titan, providing the first direct measurements of its atmosphere. As the data arrived on Earth, it confirmed many of Carl's predictions. The atmosphere was composed mostly of nitrogen, much like the air on Earth, and it was far denser than anyone had previously imagined. However, the cameras could not see through the persistent orange haze to the surface below. Despite the lack of visual clarity, Carl was satisfied with the results. He understood that Titan was a prebiotic world, a place where the chemistry of life was occurring in a deep freeze. He envisioned Titan as a version of the early Earth, preserved in a state before the first organisms began to transform the environment. To Carl, Titan was a silent testimony to the fact that the ingredients for life were common throughout the cosmos, waiting in the cold for the right moment to awaken. In the year 1961, a small group of scientists gathered at the Green Bank Observatory in the quiet hills of West Virginia. Among them was Carl, a young astronomer who believed that the question of life beyond Earth was one of the most significant inquiries in the 20th century. The atmosphere of the meeting was one of steady, focused intellectual pursuit. It was during this gathering that Frank Drake presented a mathematical framework that would later be known as the Drake equation. This formula was designed to estimate the number of active, communicative, extraterrestrial civilizations in the Milky Way galaxy. You notice the calm, methodical way Carl approached each variable of the equation, from the rate of star formation to the likelihood of life developing intelligence. He viewed these symbols not as abstract math, but as a roadmap for humanity's future exploration. In 1974, Carl contributed to a historic moment in the history of communication. He helped design the Arecibo message, a radio transmission sent from the massive observatory in Puerto Rico toward the globular star cluster M13. The message was a simple, encoded image containing the basic building blocks of human life, including the structure of DNA and our position in the solar system. You feel the stillness of the surrounding jungle as the radio waves left the massive dish, traveling at the speed of light toward a destination 25,000 light years away. Carl understood that a response might not arrive for tens of thousands of years, yet he believed the act of reaching out was a vital step for a developing civilization. He saw the transmission as a demonstration of human curiosity and our willingness to join a larger cosmic community. Throughout the late 20th century, Carl became a leading advocate for the search for extraterrestrial intelligence, or SETI. He worked to secure funding and support for projects that used large radio telescopes to listen for patterns in the background noise of the universe. He spent countless hours analyzing data, looking for signals that were not produced by stars or pulsars, but by the intentional technology of another world. To Carl, the silence of the cosmos was not a sign of emptiness, but a vast field of possibility that required patience and persistence. He maintained that the discovery of even a single signal would forever change the way humans perceive their place in existence. He approached the search with a balance of skepticism and hope, always prioritizing the rigorous application of the scientific method. The telescopes continued to scan the sky, and Carl remained a quiet observer, waiting for a whisper from the distant reaches of the dark. In the mid-20th century, Carl often thought back to his afternoons in the Brooklyn Public Library. He remembered how the rows of books offered a quiet refuge from the chaotic world outside. He realized that the knowledge he gained there was more than just a collection of facts. It was a form of protection. As he matured into a prominent scientist, he noticed a growing trend in the late 20th century, where misinformation and superstition began to cloud public discourse. He saw that without a commitment to evidence and reason, people were more vulnerable to manipulation and fear. You noticed the calm determination in his voice as he began to write his final major work, The Demon-Haunted World, which he subtitled Science as a Candle in the Dark. In 1995, Carl described a world where the complexities of technology were understood by very few, while the consequences affected everyone. He argued that science was not merely a body of knowledge, but a way of thinking, an essential toolkit for a free society. He introduced the concept of the baloney detection kit, a set of cognitive tools designed to help individuals distinguish between a valid argument and a deceptive one. You feel the steady rhythm of his logic as he explained the importance of independent confirmation of facts and the danger of relying on authority without question. He maintained that the ability to think critically was the most powerful defense against those who sought to control others through falsehoods. To Carl, the light of science was like a small candle held up against a vast, dark room filled with shadows. The 20th century had seen both the incredible triumphs of science and the devastating results of its misuse. Carl believed that for democracy to survive, the citizens must be equipped with the habit of skeptical inquiry. He viewed science as a profoundly human endeavor, rooted in humility and the willingness to admit when one is wrong. He spent his final years advocating for an education system that prioritized the process of discovery over the memorization of answers. You imagine him sitting at his desk, surrounded by the steady hum of his office, carefully choosing words that would encourage others to light their own candles. He understood that freedom was not a permanent state, but something that required constant vigilance and a commitment to the truth. His message was a quiet reminder that as long as humanity held onto the spirit of inquiry, the darkness of ignorance would never fully prevail. In the quiet hours of his research, Carl often reflected on the profound link between the molecules of life and the thoughts that allowed him to contemplate the stars. He understood that the story of human intelligence did not begin with the first civilizations, but with a single, microscopic thread of information 4 billion years ago. In the mid-20th century, the discovery of the double helix structure of DNA in 1953 provided the key to understanding this ancient narrative. You notice the steady, rhythmic persistence of this molecule as it replicated itself through countless generations, carrying the instructions for every living thing on Earth. Carl viewed DNA as a vast, eternal library, an archive of survival that had been written by the slow and patient hand of natural selection. As life progressed through the 20th century, Carl focused on the moment when information began to move beyond the confines of the genetic code. He explained that for billions of years, all the knowledge a creature needed was stored within its cells. However, as environments became more complex, life developed a new way to record experience: the nervous system. You feel the gradual increase in complexity as the first primitive brains began to form, allowing organisms to learn from their surroundings in real time. He noted that the brain was a second library, one that could be updated within a single lifetime. This shift allowed for the emergence of memory, curiosity, and eventually, the ability to recognize patterns in the world. Carl was particularly fascinated by the transition from simple awareness to the depth of human consciousness. He described the brain as a place where the universe had finally begun to look back at itself. You imagine him tracing the history of the cerebral cortex, the part of the brain responsible for the complex thoughts that define the human species. He maintained that our intelligence was not an isolated miracle, but a natural consequence of the cosmic process. By the end of the 20th century, he had become a leading voice in explaining how we are the sensory organs of the cosmos. To Carl, the birth of consciousness was the moment the star stuff within us became aware of its own origin. He saw every thought as a quiet echo of the long journey from the first self-replicating molecule to the minds that now reach out to understand the infinite dark. In the late 20th century, Carl often looked out at the actual ocean and saw it as a metaphor for the universe. He stood on the edge of the water, listening to the rhythmic sound of the waves, and realized that for most of human history, we have been like children playing in the sand. He described the Earth as the shore of a vast cosmic ocean, a frontier that was both ancient and inviting. You notice the shift in human perspective during the year 1957, when the first artificial satellite, Sputnik 1, was launched into orbit. This event was the moment humanity first dipped its toe into the dark waters of the void. To Carl, this was not just a technological achievement, but the beginning of a new era in the story of our species. In 1969, the world watched as humans first set foot on another celestial body. Carl viewed the Apollo moon landings as a profound movement of the spirit, a signal that we were finally ready to leave the cradle of our birth. You imagine the stillness of the lunar surface, a place of gray dust and absolute silence, as the first footprints were made. Carl noted that these steps were the culmination of thousands of years of looking at the sky and wondering. He understood that our curiosity was a natural impulse, a desire to understand the great expanse that lay beyond our own atmosphere. The 20th century provided the vessels and the courage to begin this journey, turning the myths of the stars into the reality of navigation. Carl maintained that we have waded only ankle-deep into the cosmic ocean, and the water is inviting. He saw the various robotic missions to the planets as our first small boats sent out to scout the nearby islands. He emphasized that the knowledge we gain from these voyages is a way of anchoring ourselves in a much larger reality. You feel the steady progression of these missions, from the first grimy images of the moon to the detailed maps of the outer solar system. For Carl, the cosmic ocean was not something to be feared, but a place of discovery that called to the innate wanderer within every human being. He believed that the story of the future would be written by those who were willing to sail away from the shore and explore the infinite depths of the night. As humanity stood on the shores of the cosmic ocean in the 20th century, Carl often looked back to an earlier era when the quest for knowledge first flourished on a grand scale. He traveled in his mind to the city of Alexandria in the 3rd century BC, where the greatest repository of human wisdom once stood. The Great Library was more than a collection of scrolls. It was a research center where the first true scientists began to map the stars in the earth. You imagine the quiet halls filled with the scent of papyrus and the focused silence of scholars who understood that the world could be known through observation and reason. Carl viewed this library as a precursor to the modern observatories and universities that define our current understanding of the universe. In the year 240 BC, a scholar named Eratosthenes, who served as the director of the library, performed a simple yet profound experiment. He had read in a scroll that in the southern city of Syene, at noon on the summer solstice, a vertical stick cast no shadow. He noticed that at the same moment in Alexandria, a stick did cast the shadow. You feel the steady logic of his thought process as he realized that the only way this could happen was if the surface of the earth was curved. By measuring the angle of the shadow and the distance between the two cities, he calculated the circumference of the earth with remarkable accuracy. This was a moment when the human mind used geometry to grasp the scale of the entire world, centuries before the first ships would sail around it. The Library of Alexandria also housed the work of Aristarchus of Samos, who proposed in the 3rd century BC that the Earth was a planet that revolved around the Sun. This was a vision of the cosmos that would not be widely accepted for another 2,000 years. Carl often reflected on the tragedy of the library's eventual destruction, which resulted in the loss of countless works on astronomy, mathematics, and history. He noted that when the library burned, a great darkness fell over the collective memory of our species. The progress of science was delayed for centuries, serving as a quiet warning about the fragility of knowledge. In the 20th century, as Carl walked through the modern reconstructions of such sites, he emphasized that we must protect our shared wisdom. He saw the modern scientific community as the spiritual successors to the librarians of Alexandria, tasked with ensuring that the light of inquiry is never extinguished again. In the late 20th century, as Carl reflected on the lost wisdom of the ancient world, he turned his attention to the pressing challenges of the modern era. He observed that while the Library of Alexandria was destroyed by external forces, the 20th century brought a new kind of risk, the potential for humanity to destroy itself through its own technology. You notice the shift in his message during the 1980s, a decade marked by the silent tension of the Cold War. He began to use his platform to speak not just of the stars, but of the urgent need for global cooperation. He maintained that the perspective gained from space exploration was the most powerful tool for fostering peace. From the vantage point of a spacecraft, the political boundaries that divide nations disappear, leaving only a single, interconnected world. Carl was a vocal advocate for nuclear disarmament. fearing that the same scientific principles that allowed us to understand the sun could be used to extinguish life on Earth. In 1983, he co-authored a study on the concept of nuclear winter, describing how a global conflict could loft enough soot and dust into the atmosphere to block out the sun for years. He explained that such an event would cause temperatures to plummet and agriculture to fail, leading to a planetary catastrophe that ignored national borders. You feel the steady, sobering logic of his argument as he emphasized that in a nuclear age, the fate of one nation is inextricably linked to the fate of all. He viewed the Earth as a fragile island of life in a vast and indifferent cosmic ocean, a place that required our collective stewardship to survive. Throughout his final years in the 20th century, Carl frequently spoke about the concept of being a citizen of the cosmos. He believed that our shared biological heritage, the fact that we all carry the same DNA and are composed of the same star stuff, should outweigh our cultural and political differences. He encouraged a sense of planetary identity, where our primary loyalty is to the human species and the Earth that sustains us. You imagine him standing before a global audience, his voice calm and resolute, reminding us that we are a single family navigating the dark together. He taught that our survival depends on our ability to transcend ancient tribalisms and recognize our common destiny. To Carl, the study of the universe was a lesson in humility and a call to cherish the only home we have ever known. In the year 1990, as the Voyager 1 spacecraft approached the outer edge of the solar system, Carl made a request to NASA that initially met with resistance. He proposed that the craft turn its camera around one last time to take a photograph of Earth from a distance of 6 billion kilometers. He understood that at such a vast scale, our world would appear as nothing more than a tiny speck of light against the immense dark. You noticed the quiet anticipation in his thoughts as the command was finally sent through the void. When the image finally arrived, it showed a grimy, dark expanse interrupted by a few rays of scattered sunlight. Suspended in one of those beams was a single, lonely pixel of pale blue. Carl used this image to craft what would become his most enduring message to the 20th century. He sat down to write a reflection that invited everyone to consider the reality of that small dot. He noted that every human being who ever lived, every king and peasant, every lover and hater, every creator and destroyer, had lived out their entire lives on that minute fragment of dust. You feel the steady, humbling weight of his words as he described how the vastness of space renders our local conceits and frequent wars entirely insignificant. He observed that from this distance, there is no sign of outside help coming to save us from ourselves. The Earth is the only world known so far to harbor life, and for the foreseeable future, there is nowhere else for our species to migrate. During his final years, Carl frequently returned to the lesson of the pale blue dot. He maintained that this perspective underscores our responsibility to deal more kindly with one another and to preserve and cherish the only home we have ever known. You imagine him looking at the photograph, his eyes reflecting the quiet calm of a man who had spent his life trying to bridge the gap between the terrestrial and the celestial. He believed that the image served as a necessary correction to our delusions of self-importance. To Carl, the dot was a silent witness to the beauty and fragility of existence. It was a reminder that in the vastness of the cosmic ocean, our survival depends not on our power to dominate, but on our capacity for compassion and wisdom. He left the 20th century with this final, visual testament to our shared humanity, a quiet call to protect the small blue world that sustains us all. In 1994, Carl received a diagnosis that shifted his focus from the vast distances of the outer planets to the intricate world of his own biology. He was diagnosed with myelodysplasia, a serious bone marrow disease that required intensive medical intervention. For a man who had spent his life exploring the mysteries of the 20th century, this was a new and deeply personal frontier. You notice the same methodical approach he applied to astronomy as he began to study the details of his condition. He looked at his own blood cells under the microscope with the same curiosity he had once reserved for the craters of Mars. He did not seek refuge in ancient superstitions or easy comforts. Instead, he relied on the same scientific principles he had championed throughout his career. During the mid-1990s, he traveled to the Fred Hutchinson Cancer Research Center in Seattle for treatment. He underwent 3 bone marrow transplants with the marrow donated by his sister, Carrie. You imagine the long days he spent in hospital rooms, surrounded by the hum of medical equipment and the steady rhythm of intravenous drips. Even as his physical strength diminished, his mental clarity remained sharp. He used his time to continue writing, working on the chapters of what would be his final book, Billions and Billions. He wrote about the beauty of the natural world and the importance of scientific literacy, even while facing the reality of his own mortality. He maintained a steady and calm demeanor, finding peace in the understanding that he was a part of a much larger cosmic cycle. In 1996, the challenges to his health became increasingly difficult to overcome. He spent his final months at home, surrounded by his family and the thousands of books that had been his lifelong companions. You feel the stillness of his study as he dictated his last thoughts, reflecting on the joy of a life spent in pursuit of the truth. He spoke of his gratitude for the opportunity to have known the universe and for the love he shared with his wife, Anne Droyan. He faced the unknown with a courage that was rooted in his commitment to the evidence of the world. He did not ask for miracles, but expressed a profound appreciation for the time he had been granted. By the end of the 20th century, his journey was nearing its conclusion, but his spirit remained focused on the light of reason and the enduring mysteries of the stars. In the late 20th century, Carl often encountered a phrase that had become synonymous with his name in the public imagination: billions and billions. Although he noted with a quiet smile that he had never actually used that specific combination of words in the original Cosmos series, he chose to embrace it for the title of his final book, published in 1997. He understood that these words captured the essence of the vast cosmic scale he had spent his life explaining to the world. You notice the steady, rhythmic quality of his writing in these final essays, as he used large numbers not to overwhelm, but to provide a sense of profound perspective. He explained that there are more stars in the observable universe than there are grains of sand on all the beaches of the Earth, a fact that he viewed as a source of wonder rather than fear. Carl used the chapters of this final work to bridge the gap between the infinite reaches of space and the immediate concerns of human life on Earth. He moved from discussing the trillions of miles between stars to the importance of the atmosphere that sustains every living thing. He maintained that the sheer scale of the cosmos should serve as a foundation for a new kind of global responsibility. You feel the calm weight of his logic as he argued that because our world is so small and isolated, we have a heightened obligation to protect the environment and each other. He discussed the global issues of the 20th century, such as climate change and population growth, with the same analytical clarity he applied to the rings of Saturn or the clouds of Venus. In 1996, as he finalized his last reflections, Carl wrote about the nature of life and the absence of evidence for a traditional afterlife. He did not find this realization cold or discouraging. Instead, he expressed a deep sense of gratitude for the opportunity to have emerged from the cosmic dark for a brief, brilliant moment of consciousness. He viewed the human capacity to understand the laws of physics as a miraculous development in the history of the universe. You imagine him reflecting on the fact that he was made of the same atoms that were forged in the hearts of distant suns. His final message was a quiet celebration of the courage to see the world as it truly is, without the need for comforting myths. He left behind a testament to the beauty of the truth and the enduring power of a single, curious mind to grasp the billions and billions of wonders that compose our reality. When Carl was a young boy in Brooklyn, he often felt a sense of profound wonder that he could not quite name. He remembered standing in the quiet aisles of the library or looking at the distant stars from his rooftop, feeling a connection to something much larger than himself. He understood that this feeling was often described as spiritual, yet he did not find it in the ancient myths or the traditional rituals of his community. Instead, he found it in the vastness of the light years and the elegant precision of the laws of physics. Throughout the 20th century, Carl worked to explain that science and spirituality were not opposing forces, but two ways of experiencing the same sense of awe before the mystery of existence. In 1985, Carl was invited to deliver the Gifford Lectures at the University of Glasgow, a prestigious series focused on natural theology. You notice the calm, respectful tone of his voice as he stood before the audience, discussing the relationship between the search for God and the search for the universe. He proposed that if we are to speak of the numinous, the feeling of being in the presence of something sacred, then science provides the most reliable path to that experience. He argued that the more we learn about the complexity of a cell or the birth of a galaxy, the more profound our sense of wonder becomes. For Carl, the truth discovered through evidence was far more majestic than any story created by human imagination alone. Carl often spoke of the word spirit as coming from the Latin word for breath. He maintained that being spiritual meant recognizing our interconnectedness with the cosmos and the long process of evolution that brought us into being. You feel the steady rhythm of his thought as he explained the concept of being star stuff. To him, realizing that the iron in our blood and the calcium in our teeth were forged inside dying suns was a spiritual realization of the highest order. This was not a mystical belief, but a biological and physical fact that provided a sense of belonging in a vast and indifferent universe. He viewed the scientific method as a tool for informed worship, a way to honor the reality of the cosmos by trying to understand it as clearly as possible. As the 20th century drew to a close, Carl's reflections on spirituality became a central part of his legacy. He believed that a society grounded in science did not have to be a society without soul or wonder. He envisioned a future where humanity's shared awe for the universe would serve as a unifying force, transcending the divisions of the past. You imagine him sitting in his study, looking at the photographs of distant nebulae, feeling the same quiet reverence he had felt as a child. He taught that by looking through the telescope or the microscope, we are not just gathering data, but participating in a grand cosmic narrative. His spirituality was rooted in the humility of knowing how much we have yet to learn and the courage to keep asking questions in the dark. In the late 20th century, specifically in the year 1996, the physical journey of Carl Sagan reached its conclusion. After a lifetime spent deciphering the language of the stars and translating the complexities of the universe for all of humanity, he returned to the source from which all life originates. He had often spoken of the concept that we are made of star stuff, the heavy elements forged in the hearts of distant suns billions of years ago. You notice the quiet symmetry in this realization as his own atoms began their transition back into the natural cycle of the Earth and the cosmos. For Carl, this was not a departure into an unknown void, but a final act of integration with the universe he had so deeply loved and studied. The 20th century bid farewell to its most eloquent spokesperson for the stars, yet his presence remained in the very elements that compose the world around us. You imagine the Voyager spacecraft still moving through the absolute silence of the interstellar void. They carry with them the records he helped create, drifting far beyond the influence of our sun. Even as his life on Earth ended, a part of his vision continued to sail across the cosmic ocean. He viewed these robotic emissaries as the first steps toward our future as citizens of the cosmos. He maintained that our destiny was not to remain forever confined to a single world, but to eventually find our place among the star systems we once only watched from rooftops and libraries. The steady, unchanging rhythm of the universe continues, and Carl's work ensures that we are no longer strangers to the vastness. The maps he helped draw and the questions he encouraged us to ask remain as a guide for the generations of explorers yet to come. He left behind a world that was slightly more aware of its own significance and its profound fragility. He taught that to be a citizen of the cosmos is to recognize that our local differences are eclipsed by our shared origin. You feel the profound stillness of this perspective as you look up at the night sky. The stars are no longer distant, cold points of light, but the ancient ancestors of our own biology. He believed that the universe is a place where we can finally find a sense of belonging, a home that stretches across light years and eons. The story of Carl Sagan is the story of a curious mind that found peace in the truth, reminding us that we are a way for the cosmos to know itself. The light from the most distant galaxies continues to travel through the dark, and the journey of the human spirit among them remains an ongoing and beautiful narrative.